Hello everyone, we are Group 16. My name is Girish and my team members are Ashutosh Kumbhar, Rajesh Sawant, and Mitesh Parab. And the name of our programming language is Mlang. So let me start off with a question. What if coding didn't feel so technical all the time? What if it felt more like telling a story, directing a scene, or writing just a screenplay? That's the idea that sparked Mlang, programming language that brings together storytelling and the software logic together. Instead of just the dry syntax, we use cinematic terms like cutIf, plot, montage, and wrap, making the code feel more alive and narrative driven. Mlang and narrative driven. So can we move on to the next slide? So the overview of the language is the Mlang follows an imperative paradigm. It also uses in dynamic typing. It is interpreted, and its syntax is inspired by film editing with the keywords like cast, cut, montage, and etc. Uh, Next slide, please. And some of the key features that we are really proud to include. The first one is the cinematic storytelling syntax, the natural screenplay style keywords like cut, plot, that makes your code read like a movie script. The second one is the interpreted execution with ANTLR and Python. Mlang is fast using ANTLR and run through a custom Python interpreter. It allows dynamic and flexible execution. The third one is the control flow and the flow support. We have got all the essential, like the if statements, the else, while, the for loops, the break, and continue, and they are reimagined as roll, while, and etc. The fourth one is the dynamic typing and expression handling. No static types are needed. It supports arithmetic, Boolean, ternary expressions, and functions with also inferred types. So the next side, we can see all the tools and technologies which have been used. The first one is the Python. It is used for building the interpreter and the runtime environment. The second one is the ANTLR. It is used to design and generate the lecture and parser from the grammar. The third one is the VS Code ID. It is the primary ID used for grammatical design and interpreter development. Then we have used GraphBase in PyDot for generating beautiful fast trees and visualizations. Then we have also used GitHub for the version control and collaborative development, and Slack for the team coordination and communication. Now I'll pass on to Rajesh.
Okay, so before we look at the internals, let's briefly talk about the design goals that we had in mind. Yeah. So since our architecture directly reflects these, so first of all, we aim for narrative readability. So we wanted the Mlang to feel like storytelling language. So we replaced traditional keywords with the cinematic ones. More on that later. But yeah, this makes Mlang fun and intuitive and accessible, especially for the beginners. And secondly, we are using modular grammar or using ANTLR, so it is easily extendable. So it would make adding new feature easy, and it will help the collaborative work. And finally, for the execution flexibility, Mlang uses the Python tree walking interpreter. There is no compile step. You don't have to compile anything. You just have to write the code and run it. With dynamic tapping and instant feedback, it's ideal for learners and to experiment and prototype. So now let me walk you through the behind the scenes and the architecture. So first part, that's our source code. Everything begins with the source code. Users write their mblank script using the cinematic syntax, like cast for variable declaration, roll while for loops, and so on. And these files with the mlan extensions are stored in data directory. Next is the grammar definition. This is the probably the most crucial part of our language, and it's done in mlang.g4 file. It defines the syntax of our language. This includes the lecture rules like IDs, strings, and parser rules like the variable declaration or the if-else statements. So ANTLR takes this grammar file and generates three main components, which are lexer, parser, and the visitors. Uh, they, these files are in Python. So this steps transforms our informational uh, cinematic code into structured grammar understood language. Next step is the lexical analysis step, which is done by the mlang.lexer. Uh, so here in this step, the mlang source code is split into tokens. These tokens are meaningful tokens are like the cast that is being used as a keyword for the uh, to declare a variable, or for example, 5 is interpreted as an integer value. The next step is parsing. So the parser uses these tokens to build a hierarchical structure known as parse tree. And this tree represents the grammatical structure of the code, which statements belongs where, which expressions are nested, what's the flow of the execution, and so on. And in order to visualize it better, we added an extra step and add using GraphViz and PyDot. It generates the parse tree in a PNG format, which helped us to debug and refine the grammar more. And next crucial part after generating the parse tree is to interpret it. And for that, again, our interpreter is written in Python. So it's a tree walking interpreter. It visits each node of the parse tree using the visitor pattern. So whenever it encounters, for example, cutIf condition, it will check the condition, execute the block if it is true, or it will go to the else part, that's plot twist in our case. Okay. Similarly, for the loop statements, it checks for the initialization conditions and update, and so on. So after it is being the code is interpreted, we'll go to the runtime environment, and here under the hood we are using a Python dictionary as a symbol table. So it keeps track of all the variable states, function definitions, and scopes. This dynamics stage allows Mlang to be flexible and easy to modify on the fly. And finally, the output is in this R case is being here been shown on the console to the print statement, or say in our case. So this is the way how Mlang communicates it back to the user. So yeah, to sum it up, Mlang blends ANTLR with Python interpreter, and more on the grammar. Mitesh will explain on the grammar part. Thank you.
Thank you, Rajesh. Now, before we dive deeper into all the grammatical nomenclature, all the functions, uh, let's have a quick overview of Mlang's building blocks. Mlang supports all the primitive data types like int, bool, string, and it uses a type interference. As you can see in the example, cast x is 10. It automatically knows x is an integer, so no need to declare the data type. Coming to the control flow. Control flow, Mlang gives us an expressive tool like cutIf and other conditions, also loops and it's designed to read like a story, not just a code. Functions are defined using scene and other kinds of terms that we are going to look in our further slides. Next slide, please. Okay. Let me start by introducing how Mlang basically handles programming syntax and control flow. The first thing you will notice is that Mlang feels more like reading a movie script than writing a code. When we need to make decisions, we use cutIf, and for alternate paths, there's alt cut and plot twist. This gives Mlang really narrative feel when you are writing a conditional logic. And for loops, instead of writing while and for, we have roll while and montage to run the sequence like a cinematic training scene. These structures still do exactly what you would expect, but in more creative and readable way. Next slide, please. Coming to functions and expressions. In Mlang, writing a function really feels like writing a scene. You start with scene, you define parameters with, and end with cut. Inside, you write your logic just like any code of block, except here you return with wrap. Expressions also flow natural language. We still have standard operators like plus, minus, and star for multiplication. We can also it also has comparison operators, but it has a different name as same as smaller than for comparisons. It's a great balance between expressiveness and precision. Can we move to the next slide, please? Um, Basically, reserve words because Mlang relies on cinematic language. It reserves certain keywords to preserve its storytelling structure. Words like cast, say, cut, scene, wrap, etc. are all reserved and can be used for variables or function names. As you can see in the PPT, all are mentioned for different types of functionalities, control flow, language syntax, and others. This helps to keep the syntax clean and avoids confusion between your code and the language's built-in storytelling commands. Thank you. And I would like to hand over to Ashutosh to explain the code.
Thank you, Mitesh and team, for giving us details about architecture and the grammar of the programming language. Now, I'm going to walk you through our program code and how we actually write code in Mlang, and some information about interpreter and lexer. So let me share my screen quickly. I believe that my screen is visible. Is it?
Yes.
Okay, so first of all, let me walk you through the project structure. So we have three main folders. Our data folder contains all the parse trees that are generated by our parser and example programs that we are going to run right now. The doc folder contains all the documentation related to this programming language. And our source folder contain our grammar code and our interpreter. Uh, Let me show you an example program first, then let's dive into the interpreter. So, as Mitesh discussed about the grammar of the programming language, you can see that we can declare a variable using cast. There are we can declare conditional statements using cutIf, alt cut, plot twist. We can declare loops using montage. We also do have a roll while loop, which resembles to the while loop in the Python. Let me come to the grammar part. So here we have declared the grammar of our programming language as we have basically used ANTLR, which supports the G4 structure, grammar structure. So here all the grammatical statements are mentioned. Coming to the interpreter, so interpreter is our programming language is kind of interpreted programming language. So this interpreter helps us interpret our programming language into the basic Python program. uh, Again, as we are using ANTLR, these are the auto-generated files such as mlang, lexer, listener, parser, and visitors. Okay, now let me show you how to run the mlang code really quick. So the scripts to compile and run mlang code is mentioned in README file. So to compile the program, we are going to use ANTLR. So this compiles our grammar and generates the 4 files that I mentioned, Lexer, parser, visitor, and listener. And to run a program, we will just write a script. Now, what this does is the main.py, we have written a code to generate uh, parse tree and yeah. So there is one file called as runtest.mlang. Inside, all the features are declared. All the features of programming language are implemented. So we can just run it. You can see that all the test cases are passed. Uh, yeah. So coming to the future scope of this programming language, so we want to add support to more data types like arrays and dictionaries. We want to also introduce operators such as bitwise operator and logical XOR. And we also would like to implement error handling for better debugging. In case of tooling, we would also like to introduce an Mlang plugin for IDEs such as VS Code for syntax highlighting and auto completion. Performance-wise, we would like to convert this intermediate programming language into compile time language, so which can generate a bytecode for performance improvement, similar to Java. And also coming to the application of Mlang, Mlang can be used for in as an educational tool to teach programming language concepts. And also Mlang can be adopted by specific domains like storytelling, game scripting, and data visualization. So that was all from my side. I believe that Mlang is a unique and engaging programming language that combines storytelling and programming, and it has a great potential for further development. Thank you.